Hello everyone, welcome to the lecture series on fundamentals of generative AI and the large language models. We are in the week 4 and week 4 is all about the advanced VAE concepts and the practical applications. And in this particular session, let us look into one of the most important concept called latent space interpolation. And by now you must have understood that VAE is mainly responsible for generating data. If it has to generate the data, what all different ways? One of the important concept has to be an interpolation. What is interpolation? Let us first understand and then we will get into the math behind. So, this is what is an interpolation. Now, whenever you want to do an interpolation, you require two inputs. You require input A and B. So, here let us take the start image or the first image as 3 and the end image as 8. Now, so far from our previous session and from all the sessions of VAE, we have understood that whenever an input is being passed to an encoder, encoder has to give us the latent space. And the latent space cannot be a single number, it will be a vector, all that we have already seen it. So, now let us understand that when an input 3 is passed to an encoder, encoder has obtained or given this particular latent space. Okay, what is the next step? Now, by now you should be knowing that how to obtain the latent space, right? In case if this is not very clear, you can go back to the previous week 3, and the last session we had done a numerical example. So, you can once again look into that particular session before you come here, so that you will be able to understand how each of these terms you will be understanding more clearly. Mathematically also you will be understanding. So, input is passed to an encoder and we obtained the latent space. Once you get the latent space, what is that we are passing that latent space to? A decoder. What is the role of a decoder? Decoder has to generate the data back or reconstruct the data. So, now when you have passed this input to an encoder with this latent space, when you passed it to an decoder, let us assume that we obtained this as a reconstructed image. Although it will not be a blue, it is just for a visualization. So, you will be having reconstructed of this particular 3, not exactly 3, you will be having an image which looks similar to 3, maybe little blur. So, but you will be getting 3 but not this blue box. No, this is your reconstructed image. Now, you take this input, forget about the rest middle 3 whatever, I will come back to that. Now, we have an end image. What is this end image? Here the image is hand digit 8. That you pass it to an encoder. What is the role of an encoder? It has to produce us the latent space. This latent space pass it to an decoder. What is the role of a decoder? Decoder has to reconstruct or generate the data back. So, here let us assume the decoder has given this particular data. Now, what is interpolation? Interpolation here is, now you want intermediate data, in between data. Now, if you have in between data, all what you have is input. This input and this input is all what we have. But from this input, we got the latent representation. Is it not? We got this as the first latent representation and we got this as second latent representation. Is it not? We definitely have these two with us. Yes. Now, once we have these two, which means here you have in terms of a number, it is a vector, it is in terms of a number. Here also you have in terms of a number vector, right? Now, from both this latent space, can I do some sort of a mixing? Can I do some mathematical operation so that from this can I get this z, right? Now, from this can I get this z? From this can I get this z? Now, at the same time, you cannot use only one latent space. I cannot use only this and then get this, only this and then get this, because what we are discussing is interpolation. Interpolation is between these two. Can I use some sort of a technique or math where you have this latent representation and you have this latent representation? Can I combine these two latent representation very systematically, and can I get this from these two by combining in a systematic way? Can I get this latent representation? Can I get this latent representation? So, from this and this, when you are getting these three, is it not the from there when you pass it to a decoder, decoder is going to reconstruct or generate the data, and that data will be definitely similar to between 3 and 8 only. Are you getting this intuition? So, now our ultimate aim is you want the intermediate images, but all what we have is the first image and then the last image. We have only these two. From these two, if you have to get the middle images or intermediate images, but yeah, we cannot imagine what can be those intermediate. So, between 3 and 8, not necessarily that it can it can be any image that can be between 3 and 8. But systematically, if you have to interpolate between these two, then all what we have is the latent representation of 3 and latent representation of 8. So, if I have a latent representation of these two, and so which means I have this latent representation and this latent representation. Some systematic way can I combine these two latent representation and get the intermediate latent representations? Can we think in that way? It's possible, right? Once I have one vector and the other vector, can I use some means to combine these two? How to combine, we will see in upcoming slides. But by combining, is it not I get one more latent representation, one more z I get? By combining in a different way, you get one more z. By combining in one more, you get one more z. So, once you get different z's, each z is passed to a decoder. Role of a decoder is to reconstruct. Is it not? This z will be very much similar to this and this. This z will be very much similar to these two. Not very much, but it will be closer. If that is the case, intermediate images also will be closer. I hope the intuition is clear. I hope the theoretical concept is clear to you. This is all about the interpolation. Now, you can ask where exactly we will be using this. One of the classical example is, say we are working on medical application. We have a patient who has come when the patient was in an initial stage of some tumor. Then we have the patient did not come back to hospital again. Patient went back to some other hospital. Then after well grown tumor, the patient came back to the same hospital. So, in between we do not have the data at all. So, but ideally we want to analyze how the tumor has progressed over a period of time. What was the size? So, in such application, the patient did not come back to the hospital, but we want to see how the progress would have been. So, in that case, I have an initial image, I have an end image. So, with that, can I get an intermediate images? Will it not be much beneficial for a better analysis, better diagnosis? Can we think? Can you imagine? Can you imagine this particular application? So, this is where we have an interpolation concept which comes into. And how is that we do? We can do that with very much with VAE only, but all what we need is an interpolation concept, which is a simple math. Let us see in detail how it is. First, you have passed an input image 3. So, let us assume those features image which is in matrix form. When you convert it into a single vector, is it not you have one dimensional one that you pass it to a hidden layer. See, this is exactly similar to week 3 last numerical example. You can just go back once so that you will understand what what exactly is being explained here. So since the latent representation size is 2, we get a 2 mean, 2 log variance. From log variance you will be converting it into an variance and then the standard deviation. We know that. So we are getting a variance. Since the latent space is 2, dimension is 2, we get 2 mean, 2 variance. From this, can I get Z? So what is that? Is it not we get Z1, Z2? So instead of Z1, Z2, here I am slightly changing the names. Instead of calling it as Z1, Z2, I am calling it as ZA1, A2. Why ZA1, A2? Because this is the first image. That first image we are considering it as XA. I hope this is clear to you. So this is how you calculate ZA1 as mean 1 plus variance sigma, and then you have this particular value sampled from a normal distribution, right? You do this. Now you have even Z2 also, ZA2. Now let us assume this is the mean value that we have obtained, and from towards the end we have calculated, and this is the ZA value that we have obtained. When I say ZA, it is ZA1, ZA2, or from that particular session terms if you have to write Z equal to Z1, Z2. This is what we have obtained. I hope this is clear so far. Nothing we have done. We have passed an input to an encoder. Towards the end of the encoder, we are getting Z1, Z2, ZA1, ZA2 for this particular input. Which means what we have discussed so far, we have reached to this step. This is what we have reached to this. Okay, now let us go back and then see what will happen when you pass the second input. Is it not the steps will remain the same? You have this input, which means you have to pass it to an encoder, and the encoder will give these parameters. From this, is it not you will get a Z? So you will get now ZB. Why ZB? Because this is a second input which is denoted as XB, and since the latent representation is having 2 vectors, ZB1, ZB2, right? This is how you calculate it. I hope up till this part it is clear to all of us. So let us assume this is a ZB latent representation that we have obtained. How did we get? I am just giving one direct example. After doing all of the calculation, let us assume this is ZB that we have obtained. In order to understand, you can solve the problem once again so that you will be able to understand this. Okay, now what we have with us is these. We have ZA and we have ZB, which means go back to our initial diagram. We have an input, that from that input we got the latent representation. We have a second input, from there we got the latent representation. That is what are ZA and ZB. How did we get? It is a simple feed forward calculation. Now from here, now you need an intermediate. Let me use another pen so that you will be able to understand. Now you need an intermediate latent one. Can we have an intermediate latent? So that when this is passed to an decoder, we get one image. When this is passed, we get one image. When this is passed, we get one image, one image, one image. And this image and this image, intermediate will be closer. That is the whole concept. Okay. So which means now you require that intermediate latent representation. So now we perform latent space interpolation. Why? Because input and output you cannot perform interpolation. All what we have is the compressed representation of that input, which is latent space. How is that you do? You require some systematic way to combine those two latent space. So this one and this one you are considering, and from here in a systematic way you are combining those two latent space. What is the formula we are using? It is 1 minus alpha ZA plus alpha ZB. Now what is alpha here? It is an parameter, hyperparameter or interpolation parameter that mainly controls the movement. How much you want to move from ZA to ZB. How much? So, in a very systematic way, you are you are moving from ZA to ZB. So that you will have, when you are moving from ZA to ZB, is it not we are getting the intermediate representations? Right, this is all about the interpolation. So now how are we doing? We are taking both these latent representations and we are combining. How are we combining? This is the formula that we have used, 1 minus alpha ZA plus alpha ZB. Now what is these alpha values? Alpha values are those intermediate values. You see, if the alpha value is 0, suppose if you take alpha value as 0, just substitute the values in this. Can you substitute 0? 0 into any term, then 1 minus 0, you are getting ZA. If it is ZA, is it not this latent representation? This ZA latent representation, when you pass it to a decoder, you get this original input reconstructed one only. That is what, when alpha is 0, we get exactly ZA. How ZA? Just substitute the values back into that formula, and since 0 into something will be 0, 1 minus 0 is 1, 1 into ZA is ZA. We get exactly ZA, which actually represents the image 3, handwritten image A or image 3. Similar way, what is the last value? The maximum alpha value that you can take is between 0 and 1. Between 0 and 1 only we can take, we have to take. Now what is the alpha value? Alpha value, if it is 1, what is going to happen? Substitute 1 minus 1 value is 0, 0 into something, this term becomes 0, 1 into ZB is ZB, right? We get exactly ZB, which is nothing but this, and when you pass that to a decoder, we get exactly that image B. What is image B here? Handwritten 8, digit 8. So you understood this concept here. Alpha value can be anywhere between 0 and 1. When you take it as 0, we get the first image. When you take it as 1, we get the last image, that is the second image. Now in between we need, so what should be the alpha values? Here in between alpha values, what we have considered are 0.25, 0.5, 0.75. These are the in between values that we have considered. Now let us calculate how exactly we get when alpha value is 0.25. Now you can look into this particular formula. Here this is since our latent space, for example, here is having a 2 dimension. There are 2 such values in our latent space. So if that is the case, how is that you expand the formula? The formula is given here. So it is once again the same, but since there are 2 terms, we are using ZA1, ZA2, ZB1, ZB2. But look into this, this entire is with respect to A1, okay, this entire is with respect to second. So this is the formula. Rather than me reading out this formula, you can see, so that you will be able to understand it much better. So this is the overall formula, but since we have 2 such terms, we are having 2 here. Ultimately we should get 2, right? What are those 2? Those 2 are, first one is with 1, that is ZA1, B1, and the second is with A2 and B2. Let us take with one numerical example here, you will be able to understand. Now what is this is ZA1, this is ZA2, this is ZB1, and this is ZB2. Right? This is what are the values, and how did we get those values? These values are these. Now perform a simple calculation. What calculation? Whatever is the formula that is given here. So what is the formula? So let me erase this so that it will be clear to you. So the formula here, it is ZA1, ZA2, this is ZB1, this is ZB2. Now substitute the values into this formula. What is this? 1 minus alpha. What is alpha term? Alpha term is 0.25. 1 minus 0.25, is it not 0.75? Right? So, that is what is 0.75 into ZA1. What is ZA1? This is ZA1 you have written, plus you have this plus. This is alpha. What is alpha? 0.25. What is this? ZB1. What is B1? This is B1. You have substituted. I hope you have understood. Perform the calculation, you get the first term. Now, you should get the second term. Why you should get second term? Because see, ZA is a two-dimensional one. If it is two-dimensional, intermediate also should be two-dimensional. This also should be two-dimensional. And ZB is once again two-dimensional. So, all our intermediates should get two values, because there are two here. If you have to get two, first we have calculated. Second term is this 1 minus alpha. Since alpha is 0.25, 1 minus alpha is 0.75, this value. And what is this? ZA2. What is ZA2? This is ZA2 plus alpha. Alpha is 0.25. And it is ZB2. This is ZB2. This is ZB2. Calculate and you get this value. Now, understand what we have done. All what we had was ZA, we had ZB. From ZA, ZB, is it not we have obtained intermediate latent representation? Is it not we have obtained, and what is this? It is 0.25. What value we have obtained? Now, can you see this value and what value we have obtained in ZA and ZB? Is it not slightly it is matching? Can you see? It is very much matching closer to this. Closer, I am not saying exactly, but it is closer, which means now if ZA is 3, the next one will be very much closer to 3 only, but not exactly 3. So, look at this ZA and look at this value. Is it not the value, look at the second term, is it not little high and the first one is little less? So, is it not when this value is passed to a decoder, decoder will generate an image very much closer to 3. Are you getting this? Right? Yeah. Now, similar way alpha value is 0.5. So, same calculation once again you perform. Since alpha value is 0.5, 1 minus 0.5 is 0.5 and alpha as it is 0.5. So, get the values from our previous slide. From here get ZA, ZB value, substitute in the formula given and then get the intermediate latent representation. This is what is the intermediate latent representation. Then take alpha as 0.75, 1 minus 0.75, we get it as 0.25, that is what is 0.25 and alpha value as it is. Okay. So, now are you seeing in the previous one, here you are taking 0.75 portion of ZA, 0.25 portion of ZB, right. Then here you are taking 50% of ZA, 50% of ZB. Then here you are taking 25% of ZA, 75% of ZB. So, therefore, you have obtained the values in this way. I hope this is clear to you. You know what we have done is we have obtained an interpolation, and interpolation on what? Not on input but on latent space. Finally, is it not this is the value that we have obtained? So, ZA, when you pass it to an decoder, ultimately it is the latent space which is denoted as Z, that has to be passed to an decoder. When you pass it to a decoder, decoder will give us the reconstructed one or generated one. So, when ZA is passed, you get XA hat. When Z 0.25 latent space is representation is passed to a decoder, we get this value. When Z 0.5, which is this value, when you pass it to decoder, you get this. When 0.75, this value, when you pass it to decoder, we get this. Finally, ZB, when you pass it to decoder, we get this. What did we do? Did you get this now? We have come to an end of an interpolation. So, what is that we have achieved? Our ultimate aim is, it is a generation concept. If it is a generated one, it has to generate some data. So, if it has to generate the data, I have only input and this input. First input and second input. With the inputs, I cannot get intermediate inputs, images. But from input, you have converted into a latent space. That latent space, if you can interpolate it, that if you pass it to a decoder, decoder will ultimately generate the data, which will not be similar to this x and this 3 and 8. Is it not very slowly you are moving from 3 to 8? Right? How much? Now, you are not moving in a random way, you are going in a systematic way. You are taking some portion of this, some portion of this, and you are combining. Next time you are taking some more portion of this, some more portion of that, and you are combining it. So, finally, the generated images will change something like this. First you have an digit 3, then you will get a 3 like intermediate image, then you get a mixed of 3 and 8 image, then you get 8 like an image, and you get a digit 8. So, this is all about the latent space interpolation, because we are moving smoothly, systematically between the two latent points in a very learned latent space. So, not in a random way, in a very systematic way we are moving. So, if you have to understand this diagrammatically, so can you able to see this? You have an input image here, and you have another input image, and can you able to see this part, how it is getting changed? I want you to visualize this. So, for a better understanding, I have taken it from an internet source. I give the complete credit to this particular author. So, is it not as you are changing, you are getting a different variation of, and towards the end, is it not moving closer to that particular second image? So, this is what is an latent space interpolation. One of the important applications, especially whenever you are working on those applications where you do not have an intermediate data, but you require to analyze that intermediate data also, then latent space interpolation will be a very good concept which you can explore. With this, we have come to an end of week 4. And in the next 2 sessions, you will be seeing an hands-on implementation of the concepts that you have learned in this particular week. Thank you.